So yesterday we looked at independent events. Today we're going to focus on dependent events, and dependent events are also sometimes referred to as conditional probabilities. So a dependent event would be affected by something else that's already happened. Okay, so if you have two things happening at the same time, say you're drawing from a deck of cards, and you draw one card and you get a 5, that's going to affect the probabilities. If you don't put that 5 back, it's going to affect the probabilities going forward. Okay, so for this first example, it says 2 red checkers and 2 black checkers are placed into a bag. What is the probability that a red checker is randomly chosen, followed by a second red checker, assuming that the first checker is not replaced? So this is a similar question to the highlighter question that we did yesterday, except that in that case, we were replacing the highlighters before we took a second one. So that kept the probabilities the same. When we don't replace it, they're not going to be the same. So we want the probability that we get a red followed by a red. So again, we're going to multiply the probabilities together. They're just not going to remain constant. So the probability of getting a red checker is going to be 2 out of 4 or 1 out of 2 for the first one. When I go to draw the second one, now there's only 3 checkers left to choose from, and only one of them is red. So my probability of choosing a second red is going to be 1/3. And then we still multiply those together to get our final probability. Okay? So see how when you do not replace, that changes your second probability. Whereas yesterday, it would have remained constant, 1/2 times 1/2. The outcome of one trial has been determined, then the conditional probability of a subsequent trial can be calculated based on the results of the first trial. So that's what we just did. We calculated our probability based on what happened in the first one. Formula that you can use, the probability of A and B happening would be the probability that A happens times the probability that B happens given, that little slash there means given, A has already occurred. Okay, so in our last one, it would have been the probability of getting a red and a red checker. We had the probability of a red times, it would have been the probability of a red given we've already chosen a red. Okay, this one, you don't necessarily need to use your conditional probabilities to solve this one, but the idea is there. It says Luke is offering juice samples at Costco. The experimental probability of a shopper accepting the sample is 70%. The conditional probability of a customer purchasing the juice given he or she has tried the sample is 15%. No one purchased the juice without buying a sample. If Luke offers 500 people a sample, how many sales will he make? So the probability that they sample the juice and purchase the juice, we have this probability of a sample is 70 or 0.7. The conditional probability, so the probability that they purchased the juice given that they tried the sample is 0.15. Okay, so this is my P at S. This is my purchase given that S has happened, that they tried the sample. We multiply them together and we get a probability of 0.7 times 0.15 is 0.105. And so this times by the 500 will give us how many customers would have purchased the juice. And 52.5 or approximately 53 people. Okay? The next example says, let's assume that the probability that you will attend the University of Windsor is 1/5. The probability that you go to the University of Windsor, given that your friend also goes, is 3/4. Determine the probability that you and your friend go. So probability you and friend, and we have the probability that you're going to go, probability that you're going to go, or your friend goes, given that you're going to go. So that's friend. given you are going. So probability that you are going is 1/5. Probability that your friend goes given that you are going is 3/4. Multiply those together and we get 3/20. All right, so the next probability question. Since the Jack of Hearts is drawn from a normal deck, determine the probability that the next card is a spade, given that the first card drawn was the Jack of Hearts. So if we just kind of think about this one, the probability that we're going to get a spade, given that we've already drawn the Jack of Hearts. Well, how many spades? So we've already taken the Jack of Hearts out. That one is gone. We have 13 spades in the deck. And to choose from, because we've already taken out the Jack of Hearts, we now only have 51 cards to choose from. Okay, so this is coming up with your conditional probability based on the fact that we already know that this card has come out of the deck. And that's it. Make sure you look up the questions that you're supposed to complete.